So now that you know the basics of vectors, we can do math with them. So first, I wanted to add two vectors that are in the same direction. 20 meters at 40 degrees plus 5 meters at 40 degrees. So if we draw this, because we're walking, we draw, see, 40 is just a little bit below half. So this is 20 meters, and then 5 is about a quarter. So I'm doing this approximately to scale. It's the same direction. So our resultant, I've been doing those in red, our resultant is 25 meters at 40 degrees. That's nice. Now what about simple multiplication? If I want to do 3 times 5 meters at 70 degrees, well, remember that multiplication is a shortcut for addition. So this is the same as saying 5 meters 70 plus 5 meters 70 plus 5 meters 70. So if I drew this, it would be 5 and another 5 in the same direction and another 5 in the same direction, or 15 meters at 70 degrees. So when we multiply, do not think of it as regular distribution. You only change the magnitude. You do not change the direction when you multiply a scalar and a vector. So the last one I want to do is subtraction. If I go back to these same two, 20 meters 40 degrees minus 5 meters 40 degrees, well, I can start with my 20 meters 40 degrees, and then remember that subtracting is adding the opposite. So the opposite would be 180 degrees the other way. So 40 plus 180 is 220 degrees. So instead of continuing on, I'm going to come back 5 meters. And then my resultant is 15 meters, and go with the angle of the bigger one. So this is 15 meters at 40 degrees. If this one had been longer, the answer would have been whatever positive magnitude at 220 degrees. So that's the easy stuff. But what if the vectors are not collinear? These are on the same line, these are on the same line. Of course, these are on the same line because they are collinear. That's a good word. Same line equals collinear. So if they're not on the same line, I'm going to define two vectors. A equals 5 meters at 40 degrees, and B equals 20 meters at 160 degrees. Notice the symbol I used here. You know that A is a vector because I put the half arrow on top of it, kind of like the ray symbol you used in geometry. If printed text, this is a bold letter to let you know that it's a vector. So I want to find what is 2A plus B. That's my question to calculate. So if we walk this path twice and then we do this, where do we end up? So first let's draw it. We're going to do 5 meters at 40 degrees plus another 5 meters at 40 degrees. And then we need 20 meters at 160. So 160 is almost 180. So we need almost the negative x-axis, but we need 20 degrees above that. So I'm going to go pretty shallow. And I need 20 as opposed to these are 5, so I need it about 4 times as long. That looks pretty good. 20 meters. So instead of doing this and this, my shortcut, my displacement, my resultant is this red line. Now I have managed to make that look like a right angle. I don't think it is a right angle. If it is a right angle, it is purely a coincidence. We are going to ignore that it might be a right angle because we don't know that it is. So pretend that's really more obtuse or acute. So there are 3 steps for adding general vectors. The first one is find the components. The second is do the math separately on each set of components. And finally, find the resultant. So that kind of disappeared, but that's okay. There it is. And now we have the whole rest of the notebook to do this, but it'll fit on this page. So first, I need to rewrite vector A from being 5 meters at 40 degrees as components. So 5, oh, and remember components. The x component is our cosine theta. The y component is our sine theta. And how do you remember x is cosine and y is sine? Cosine comes before sine, x comes before y. So 5 cosine 40, 5 cosine 40 is 3.8302 meters in the I, or the x direction, plus, for the y component, 5 times the sine of 40, 5 sine 40. So we get 3.2139 meters in the y direction, the j unit vector. We're going to do the same thing for b. For b, x 20 times cosine 160, 20 times cosine 160. We get an answer of negative 18.7939 meters in the I direction. And that makes sense. This is in the second quadrant, so we should have a negative x value. Plus, for the y component, we need 20 times the sine of 160. And we get 6.8404 meters in the j direction. So that was step 1. Now we do step 2. We need to do our vector math. The problem we're trying to solve is 2a plus b. So I need to do 2 times 3.8302 plus negative 18.7939, all of which is in the I direction, plus do the same thing for the j direction. 2 times 3.2139 plus 6.8404. So again, I'm doing my math on the components and I'm doing it separately. So 2a plus b, 2a plus b, 2a plus b, 2a plus b. And now you evaluate these. 2 times 3.8302 plus negative 18.7939, and we get negative 11.1334 meters in the I direction, plus 2 times 3.2139 plus 6.8404, and we get 13.2682 meters in the j direction. And now we just have to turn this component form back into the resultant. So you know we do the magnitude by the Pythagorean theorem. So I need to do 11.1334 squared plus 13.2682 squared. Take the square root of the whole thing, and the magnitude of my answer, 11.1334 squared plus 13.2682 squared equals, take the square root of the whole thing, and we get 17.3 meters. Now for the angle. You know we do the inverse tangent of the y component over the x component. So 13.2682 over negative 11.1334 equals inverse tangent 13.2682 divided by negative 11.1334, and we get negative 49.9, we get negative 50 degrees. But wait, what quadrant are we in? If we're in quadrants 1 or 4, we leave it. If we're in quadrants 2 or 3, we need to add 180. This red vector is in quadrant 2. Even if I didn't trust my sketch, I can see from the two components that negative x and positive y, that's quadrant 2. So since this is quadrant 2, I need to add 180 degrees. So my answer is negative 50 plus 180 is 130 degrees, and that's in quadrant 2. It's between 90 and 180. So our final answer for 2A plus B equals 17.3 meters at 130 degrees. And so just in case you're wondering, back in the picture, because A was at 40 and this answer ended up being 130, yes, that is a right angle. But that was purely a coincidence. It was the numbers I made up. I do not know how I managed to do that. So never assume. Do the whole thing. You get to do 4 of these in class tomorrow.